All right, here's another definition, really important for our discussion about lines and planes. So the angle between vectors, u and v, right? So here's a vector u, here's a vector v, they're in like standard position, both have initial points, at the origin. Same initial point, whatever. So the angle between these two vectors, call it theta. You can find that thing by using this formula, and we'll say where this formula comes from in a minute. So the cosine of theta is equal to u dot v divided by the magnitude of u times the magnitude of v. And another way to say this is that the angle theta is just the cosine inverse of u dot v over the magnitude of u times the magnitude of v. So these two things say the same thing. So why is that? Well, if you've got two vectors u and v, then you can complete a triangle just drawing the side v minus u. So certainly if I take u and add it to v minus u, so v minus u plus u, the u's cancel and you get the vector v. So that's where this picture comes from, and so we want to try to find this angle theta. And we want to show that this is the correct formula for finding the angle theta. So here's the pivotal step. This is the crucial observation. Where do I start? Well, right here. And where does this thing come from? This is exactly the law of cosines, right? So remember, the side opposite the angle theta, right? The length of this side squared is equal to the length of this side squared plus the length of this side squared. So magnitude of u squared plus magnitude of v squared minus 2 times the magnitude of u times the magnitude of v times cosine theta. So just if you need to refresh, like check out an old trig book, look up the law of cosines. That's exactly what this is, right? So the side length of this triangle, it's the magnitude of u. This is the magnitude, the length of this side is the magnitude of v minus u, and the length of this side is the magnitude of v. So law of cosines. So now, what is the magnitude of v minus u squared? Well, it's v minus u dotted with itself. It's the vector v minus u dotted with itself. And so this thing is equal to this thing. And so now we'll just recopy all of the stuff here on the right-hand side. So that's all we did from here to here, is use that property that a vector dotted with itself is just the magnitude of that vector squared. So now I'm going to go ahead and use properties of the dot product, right? The algebraic properties of the dot product to FOIL this thing out. So you get v dotted with v minus v dotted with u minus u dotted with v plus u dotted with u. And so remember, u dotted with v is the same thing as v dotted with u, so that's why we get two of these. And then also remember, v dotted with v is just the magnitude of v squared. U dotted with u is the magnitude of u squared. So that's all we did from here to here, is just FOIL out the left-hand side. And then we just recopy the right-hand side. So now what happens? Well, we get a bunch of cancellation, right? We added a magnitude of v squared on this side, and we added a magnitude of v squared on this side, so that's gone. And then we added a magnitude of u squared on this side, and there's a magnitude of u squared on this side added. So now we cancel, and that's gone. And now we get negative 2 u dot v is equal to negative 2 the magnitude of u, the magnitude of v times the cosine of theta. And so, of course, now we can scratch off multiplying by negative 2. So at the end, we just get u dot v is equal to the magnitude of u times the magnitude of v times the cosine of theta. And so, right, we want to assume that these vectors are not zero. Otherwise, we don't want to talk about the angle between two vectors. If one of them is 0, right, then there is no angle between the two vectors. That should be undefined. So the angle between two non-zero vectors is what we're doing here. So that being said, if both of these vectors are not 0, then that means the magnitude of this thing is not 0, and the magnitude of this thing is not 0. So now I'm allowed to divide both sides by the magnitude of u times the magnitude of v. And so here's the formula, right? Cosine of theta is equal to u dot v divided by the magnitude of u times the magnitude of v. So definitely, if you don't believe all of this, make sure you memorize the formula for the angle between two vectors. All right, here's a quick example of finding the angle between two vectors. So we'll pick an example here in R3. So let's find the angle between the vectors 0, 1, 1, I'll call that u, and the vector 1, 0, 1, I'll call that v. So here's a rough sketch of u and v. So, what's the angle theta between these two vectors? Well, according to the formula, the cosine of that angle is u dot v over the magnitude of u times the magnitude of v. So up in the numerator here, we'll find the dot product, 0 times 1 plus 1 times 0 plus 1 times 1, 0 times 1 plus 1 times 0 plus 1 times 1, and then divide by the magnitude of u. So the square root of 0 squared plus 1 squared plus 1 squared, that's this. And then the magnitude of v, square root of 1 squared plus 0 squared plus 1 squared. So in the end here, right, the numerator is just 1, the denominator is root 2 and then times root 2, so that's just 2. So now we get the cosine of theta is equal to 1/2. And so to find theta, you can just take the cosine inverse of 1/2. And of course that gives you 60 degrees. How did I know that the cosine of 60 is equal to 1/2? So here you just need to remember that cosine inverse, right? That thing is defined when you're looking at the top half of the xy plane. Anyway, so here you've got cosine of theta is equal to 1/2. That means the adjacent side is 1 and the hypotenuse is 2, and that means that this side has to be root 3. And so this is the old 1 root 3 2 triangle. And so we know that the side opposite root 3, that's going to be 60. So that's how we got cosine inverse of 1/2 is equal to 60. Again, you might need to review a little bit of trigonometry to carry out these computations. All right, here's a special case when the angle between two vectors is 90 degrees. So when the two vectors are perpendicular, what can we say about that? And when can we conclude that two vectors are perpendicular? So, just a little bit of reasoning here. Let's say we've got any two non-zero vectors. So we don't know what the relationship is between them. We just know that they're non-zero. And suppose that their dot product is 0. So two non-zero vectors, when I dot them together, I get 0. Well, if you know the numerator is 0, then that means the whole fraction has to be 0. And because both of these vectors are not 0, this fraction is defined. Because the magnitude of u and the magnitude of v, neither of those is equal to 0. So this is a well-defined fraction. So the numerator is 0, that means the whole fraction is equal to 0. But what is this fraction? It's exactly the cosine of the angle between the vectors, right? This is, theta is the angle between the vectors, and now we know that the cosine of theta must be equal to 0. Well, when is the cosine of theta equal to 0? Exactly when theta is equal to 90 degrees. Or theta could be 270, but we don't care about stuff on the lower half of the circle. We only care about stuff on the upper half of the circle. So, if the dot product is 0, then the angle between them must be 90. What about the converse? Let's suppose now that the angle between the two vectors is 90 degrees. What can we say about the dot product? Well, if the angle is 90 degrees, then that means the cosine of that angle must be 0. What's the cosine of the angle? It's u dot v over magnitude of u times magnitude of v. So now we know this fraction is equal to 0. And when is a fraction equal to 0? If and only if the numerator is equal to 0. So here's what we can glean from these two lines of reasoning. The dot product between two vectors is 0 if and only if the two vectors u and v are perpendicular. This is true when we've got non-zero vectors. So now we just want to expand a definition slightly, right? And we will say that two vectors in Rn are called orthogonal if u dot v is equal to 0. And here we do allow zero vectors. When we talk about perpendicular, we don't allow zero vectors. When we talk about orthogonal, we do allow zero vectors. So in this case, when we talk about orthogonal, one of them could be 0. So in particular, the 0 vector, because 0 dotted with anything is 0, the 0 vector is orthogonal to every single vector in Rn. So if two vectors are orthogonal and they're not 0, then they must be perpendicular. But you can also have two vectors that are orthogonal and one of them could be 0, both could be 0. But there we wouldn't say perpendicular, we would just say orthogonal. So for the most part, orthogonal and perpendicular mean the same thing as long as the vectors are not 0. Right? If the vectors are 0, then we will just say orthogonal when the dot product is 0. So memorize that. Memorize orthogonal is the same thing as dot product is equal to 0. And when the vectors, both vectors are not 0, orthogonal means the same thing as perpendicular. All right, here's a quick example. So these two vectors are orthogonal, and coincidentally, they're also perpendicular because they're not 0. Here's why they are orthogonal. Well, just take the dot product. So u dot v, 1 times 3 plus 1 times 1 plus negative 2 times 2. So that's 3 plus 1 minus 4, which is equal to 0. So this shows that these two vectors are orthogonal, and that means they must be perpendicular because neither one of them is 0.